Hello, today we're going to talk about software to simulate mechanisms and analyze mechanisms. So let's get started. Okay, the software that I'm introducing to the class is this GIM software, GIM, I'm guessing that's how we pronounce it. It's located, you can download it from the website, and you can or from our iLearn website. And there's also the tutorial that you can look at there. This was developed by this university, and if you use it for a publication or a project, something that you're going to put online, please recognize the group, this group, for their free sharing of the software. You have a couple options when it comes to software for representing mechanisms. I'm going to point out two quickly as we get started. I guess I should mention three. So the classic approach is atoms. We don't have atoms at the moment, but it's probably the strongest software. Another one is Motion Solve, made by Altair HyperWorks, and we've got a few seats of this in one of our better labs. One of the Clement Hall labs. And I did note it on Motion Solve. You can see it's integrated multi-body solutions. And you can get a free student edition for Motion Solve if you choose. You would be developing this. I need to tell you, you need to be developing this on your own. So you could download a free student edition and play with that on your own. Another software that's probably the most popular for, I would recommend, but you have to spend a little bit, is this little thing here. It's in my way. And it's called, not SimWise, what is it? It's called two-body dynamics. Let's go back to this. It's called MotionWorks. Couldn't think of the name of it. Working Model. Working Model. And so it's this Working Model 2D, and you can get this, the student edition for 6 months, $29, or 12 months, $49. It's a little bit of investment, but that's a nice software. If you actually purchase the book, you would get, Working Model along with that textbook. And there are some examples in the textbook on using that. However, that's not the option we're going to use in this class for no particular reason. We'll be using the GIM software. I think the softwares that you see will all be fairly similar. Probably this one being free would be the clunkiest, maybe the most constrained in terms of what it will do, but it is free and you can always get access to it and use it for your projects. So to open GIM, you need to go to the download GIM, extract it, and then start GIM on your computer. And that's what I'm doing here. So the first thing that we see is this general purpose workspace. And I'm going to be jumping, to the tutorial a few times. You're going to see this general purpose workspace. And there's a couple parts to GIM. You can see you've got the standard start a new file, open from existing files, save your current file. And there's a couple steps that you can do. Geometry, in geometry you create your mechanism, or they actually provide a library that you can download some mechanisms already built and start modifying those. So you create and modify here in geometry. Kinematics will do kinematic simulation. The dynamics will do dynamic simulations. So in kinematics, of course, it's motion. In dynamics, you can include forces. There's a link of synthesis. In synthesis, you actually specify the motion you want to get from your mechanism, and that will then solve or give you mechanisms that will do that problem. And then finally, there's this workspace analysis. In this short little video, I plan on talking showing you a little bit about geometry, a little bit about kinematics, and a little bit about synthesis. I'll record a second video that will talk a little more specifically on synthesis using GIM. And all this material comes from the tutorial, and then also just kind of clicking around and learning on your own. I'm not very comfortable with GIM. I mean, I don't use GIM a lot, but it's a good software, and I think you could pick it up pretty quickly after reading the tutorial. Okay, so let's start with geometry, and I'm over here. I've got the, on my screen, I've got the tutorial open, actually. And so the first page, I can see what is GIM. It tells me is this mechanism analysis software. It's very nice. Application of the software, access to the software. And again, it's noting if you use their stuff, the only thing they ask is that you cite them in any kind of publications, and they give the citations there. It has the kinematic analysis module, which is the heart of GIM. I'm guessing it's geometry in motion is what that means. And so they first start talking about the geometry motion, the geometry module. So let's look at that. So we're gonna look at the geometry module here. So I'm gonna create a very simple mechanism, and there's a couple ways to do it. The way I do it is I first create key points that are gonna recognize my mechanism. And let's say I want to create a, let's just say a simple 4-bar that we've seen. Let's think about, I'm gonna try to create something that looks like the, let's see, okay, I'm gonna stretch a little bit. We just did the elliptical machine. So I think I'm gonna try to create a mechanism that looks like the elliptical machine. So I'm gonna place a couple points that I think are key points on the elliptical machine. This is the input handle. Up here's where you grab with your hand. Here's where it's fixed to ground. Down here's where it attaches to the lower leg link. I'm gonna run the lower leg link, say over to here. And then that attaches to the crank, which comes up, and let's say the crank is here. So I've placed those points, key points, and then I'm going to start creating links between them. By the way, if I want to modify one of those points, I click this modify icon. I can come to any of these. There, I've double clicked it, and I can either move it around, or I can specify its location. It gives an orientation, but for a point, I don't know that orientation makes much sense. So I can work with these guys as follows. I'd like this to be in a line. I guess I'd have to think about how to make that in a line. Maybe I can do it by making all of them have a common X value. Here. Okay, next I'm ready to start creating my links. So to create my links or elements, I'll select this icon. And my first element is going to be the handle. So it's going to start at this point. It's going to run up to this point and then carry on, in this case, to that point. And I'm done. Now, I'm not quite sure how to tell it is done, so I'm just going to click on it. There. I guess I just clicked on that last link twice, and you can see I've got this link. That's my handle. Now I'm ready to create a second element, and that's already selected, so I'll go down and start it here. It's going to go up to there, and then I click on that endpoint twice to get it to stop. And then I'm going to create one more. So I'll go from there to there, click on it twice, and that's done. Now at the moment, this is just a rigid link of chains. So next, I want to insert some type of kinematic pair, or some type of joint. And here I've got a revolute joint, a prismatic, a double slider, a sliding revolute joint. You see my different options here. And I want to start with these revolutes. I'm going to select a revolute, and I will click on that point again. And that now gave me a revolute between those two guys. I'm going to click on this, and that broke then the link there and gave it a link. Now, I've noticed for connecting to ground, they don't give it explicitly. So if your link ends in space, you can connect it to ground just by clicking on it. So it kind of assumes, defaults that ground is there, and we'll try to do the same thing here. Yeah, okay. So there you have it. If for some reason I don't like something, I could click delete, come around and choose it. And then down here are some constraints that I could add to the device, and then I could delete these constraints down here as well. Okay, and this modify, I was just looking at the modify. I'm not sure if I can. I don't know if I can modify that. I was wondering if I could make the ground come out. Okay, anyhow, that's our mechanism. Again, you stand here, there's the crank and the back, and then the user puts their input up here. So now I'm ready to do some analysis. So I've completed my geometry. Now I'm ready to do my analysis. So I'll go to Kinematics. So I'll click the Kinematics icon. And I have a couple options. I can do single position analysis where I'll select, in all cases it's the same. I can do single position, controlled motion where define it, or some automatic motion. And we'll try some different things. Oh, I need to show you one thing. Sorry about that. Save changes. Uh-oh. Yes. Okay. It just said save changes. Okay. So when I go back, notice right off the bat, when I built this thing, it gave me the degrees of freedom and redundancies. So it's pretty nice. I don't know if you were following as I was building, but those things changed as I built. For example, if I come in and say, well, I'm going to attach another link to ground, we kind of know what would happen. Let's say I'm going to fix that to ground. What happens? Well, look, I've lost all degrees of freedom. And I've lost those redundancies. I'm going to try to get rid of that thing. Yeah. Okay. Well, I did it the hard way. So now I got to go back and create it. So I'm going to recreate the point here. I want to edit that point, make sure he's on the line. Recreate the link. Guess I'm just going to delete this. I suspect I could have done a better job at that. Now recreate the link. It goes from here to here to here. Double click on the end to stop it. It looks like it by default picked up that revolution, but I still need to connect to ground. So I'll select that. Now I'm back. Okay. So, and I'm back to 1 degree of freedom. So now I go to kinematics. I'm going to start with automatic motion. And for my automatic motion, it's suggesting some input. What I need to do is select my input actuator, and I'm going to let it be the handle here. And so that's giving me some motion. I can see my possible motion of the machine. And then finally, I'm ready to, I can animate the system if I want, like so. And so now this is the motion that I would get. It's giving me some key points along the way. I can pull information off. Oops, it's slowing down. That might be my computer slowing down, actually. Or I could step through those points. So that's kind of nice. There's several things I can see. I wouldn't know that just arbitrarily that mechanism would have worked the way I'd hoped, but it looks like this one does. Looks like this one does. I think if I were to add a middle point, it would track. Notice how it's tracking the location, all these middle points. For fun, let's go back to geometry. Take it back to the initial spot. I'm wondering if we can add a point to the middle of this link. Let's say the foot's going to be right there. I'm going to add a point there. I think I just added. Looks like I added something. Now I'm going to go back to my geometry, or my kinematics, excuse me. Do an automatic motion. Yes. See, what just happened, it's now giving me the trajectory of every point that I followed. So now that point seems to have disappeared on the drawing. That's where I want the foot to be, but you can see it's giving me the path of the foot. So, I could ask the question, they call it elliptical machine. Is that elliptical? Not quite. It's kind of there, but it's not. We could, if we made this one of these a slider, it would get elliptical. It's elliptical-like. We'll call it elliptical-like machine. Okay, so I can get that motion. There should be a way that you could find where you could get those absolute numbers and plots of those. That's the main idea. In this case, we made this be the input. I could have chosen this link to be, oh, now that's back. I could have chosen this link to be the input. That's odd. See, that point's back. But anyhow, once again, those things are all given to me. Finally, the controlled motion. If I go with controlled motion, again, I can choose an input. And now I have the option of giving the range. So it looks like this one is, I can't change the initial condition, but I can change the final. So it's starting at 60, so 63 degrees. I can make it go to 0. And that would show me then the motion for going from this 63. It must be missing the negative. That's not, oh, it must be missing a decimal point because that's actually in the negative quadrant. Sometimes it's a little hard to see. But here I'm going over that smaller portion of motion. And that's why I specify. And then note, it's also giving me the velocity right now, the angular velocity, angular acceleration of that link. And I could modify, I suppose, some of those as well. Let's say I want to go to 90. So now I'm going farther. I could go to 180. Go to 270. Okay. So I'm getting that portion of motion. Okay, so that's how the kinematics works, and you can pull out some of these parameters. You know, you can also always choose, you could choose different things to be the inputs. This chose absolute rotation, one of the links that are connected to ground. Here's a relative or floating actuator slider. We don't have any of those. All right, time to stop that. So I'm about done with this set of notes. The last thing I wanted to show you, you probably could take a little time and play with other mechanism types. What I want to do next is look at their library. So I just selected open from the library, and actually they have planar, spatial, computed, gosh, and the like. But let's just stick with our planar. And they give us a variety of 1 degree of freedom mechanisms to choose from, 2 degree of freedom mechanisms, 3 degree of freedom mechanisms, and so on. 0. Oh, trusses. Yeah, they do some truss analysis, static analysis as well. We've just created a 4 bar so far. These are all 4 bars actually, but a 4 revolute 4 bar. Let's choose another one. These would be one of our, what we call one of the slider cranks. So let's choose this guy for fun. And it just returned a default mechanism. We should have the ability to go in and, in geometry, we should have the ability to go in and move these points around if you want to change the device, okay? So here I'm changing where that link is. So this will give you the chance to pick a general topology you like. We call that a topology, but then start changing dimensions. So here I'm doing dimensional changes, okay? So let's go back to what we had. What did we have? Looks like it started there. Let's go to the kinematics. Look at the motion for a moment. Okay, so that's the motion that's returned by default. And we can go back to the geometry now and start modifying that. So I've clicked this modify, and I'm gonna start moving things around. So I can make a new mechanism, you know, some new kind of mechanism. Like so, and go back and look at the behavior of this guy. And you'll notice it's pretty easy to get motion that becomes quite not, I'm going to say, not intuitive based on the mechanism. And that's the beauty of mechanisms. Really, the power was that I could start creating complex motion. A single link is going to give me circular motion. A single link pinned to ground is always going to give me circular motion. A slider connected to ground is always going to give me linear motion. But if I want anything else or any alternative way of doing it, with just a small number of links, I start getting complex motion out of this. So that's a summary of a quick overview on GIM. The third topic that we want to look at, stop this guy, the third topic that we're going to look at is synthesis, creating a mechanism given a desired motion. So in other words, you know, I want to maybe create something that's near a straight line or some particular path. What's the mechanism that gives that? And I'll do that in a follow-on recording.